Hello everyone. In this video, I'm going to introduce our paper, Hierarchically Decoupled Spatial-Temporal Contrast for Self-supervised Video Representation Learning. I'm Zehua Zhang from Indiana University Bloomington, and this work was done with David Crandall. In this paper, we aim to learn video representations from unannotated video datasets. The goal can be achieved by properly designing a proxy task for self-supervised pre-training. And the learned representations can then be used when fine-tuning the model on downstream tasks, such as action recognition. Early work solves a problem by reconstructing the input, while later on people turn to context-based self-supervised learning. For example, by classifying the temporal order of the input video clip. Contrastive learning is very popular in recent years. It tries to maximize the similarity between values from the same instance in the feature space and minimize it otherwise. There are some attempts to apply contrastive learning to the video domain. However, they are not as successful as in the image domain when compared with context-based methods. Our hypothesis is that traditional contrastive learning methods work in a one-for-all manner. There is only a single proxy task based on features from the last layer, and therefore the network may try to memorize spatial-temporal combinations instead of capturing general spatial and temporal semantics at multiple scales. To improve, our idea is to design different subtasks, each emphasizing spatial, temporal, and hierarchical features. We first decouple the overall objective into two subtasks of spatial contrast and temporal contrast by making use of augmentations as regularization. In particular, only spatial augmentations are performed to obtain different values in spatial contrast. Neural networks are notorious for finding shortcuts. Since spatial similarity is enough for the network to finish the contrastive learning task, it doesn't have to bother with temporal information. To let the network pay more attention to temporal similarity, temporal augmentations are further employed in temporal contrast. In this way, the network will be encouraged to focus more on temporal semantics, because spatial context may vary a lot across time, and thus can hardly be used to solve the task. In order to capture multi-scale features, we perform both spatial and temporal contrast hierarchically with features from different layers. This leads to our overall objective, HDNCE. We consider features from the last three blocks of the network. Alpha and beta here indicate the significance of instance-wise consistency in each layer, essentially weighting each subtask towards main goal. Application studies support the benefits of learning with both spatial and temporal contrast, and learning at multiple scales. We also observe that assigning smaller weights to the subtasks at middle layers leads to better performance, perhaps because the instance-wise feature consistency is not as strong as that at top layers. Experiments support our design choice of keeping spatial augmentations in temporal contrast to make the spatial context as different as possible and therefore prevent cheating through spatial similarity. Our method pre-trained on Kinetics 400 achieved on par or better performance on action recognition tasks when fine-tuning on UCF101 and HMDB51 using 3 different model variants. Near-recent neighbor retrieval experiments also suggest a superiority of our method. The qualitative results in the right indicate that spatial and temporal contrast separately focus more on spatial and temporal similarity. To summarize, we propose a new self-supervised learning method, hierarchically decoupled spatial-temporal contrast. It achieves competitive performance on downstream tasks on both UCF101 and HMDB51 by getting the model to separately emphasize spatial and temporal features, as well as performing the self-supervised learning at multiple scales. We hope to bring to the community's attention that in unsupervised learning, the spatial-temporal learning decoupling and hierarchical learning may be as effective as that in supervised learning. Thank you.